Welcome to Easy Math TV. This is a video that is going to be used for one of my classes for Precalculus. Hopefully there will be more videos that we're going to add in the future for Precalculus. So for now, it's not going to be placed in a playlist, but it will be in my channel. So um, we had an introduction over the last week and a half or so of trigonometry and the trigonometric functions. Today we're going to talk about transformations of sine and cosine and what that means in terms of certain attributes. The attributes that we're going to be interested in are amplitude, period, vertical shift, and phase shift of the new function that's based on the toolkit function f of t equals cosine of t. So let's just read the problem. The problem says consider the function f of t equals 3 times cosine bracket 2 times t minus pi over 4 close bracket plus 4. So the argument of the cosine is that entire quantity 2 times the quantity t minus pi over 4. And that's the argument of the cosine. And then the cosine function itself is being multiplied by 3. And then at the end, we're adding 4. So there's a lot of changes being made to the cosine function with all of these constants that you see here. And it can get very confusing if you just want to try to memorize formulas that will help you figure out what the amplitude, period, vertical shift, and phase shift are just by memorizing those formulas. You can, but I wanted to show you how to use Excel for that. So in our spreadsheet, we're going to be using 4 columns A, B, C, and D. So right away, just get your spreadsheet set up like this and make sure that you have from A3 all the way down to D23. So this entire block of cells needs to be configured as a number. Like we need to make sure that those are numbers, in fact. So these degrees here, I'm going to make sure that those are just whole numbers. Here's our angles in radians. And I'm going to increase the decimal size for those just so you can see. And then these are all going to be numbers as well. So just make sure that everything is configured to be a number below row 2. So up here, though, these are just text. So you're going to have your headings across the top. And then row 2 is just there as to make things look pretty. That's what it's there for. I just colored it in a shade so that we could see that there's a clear designation between the headings and what comes below it. So the angles in degrees were just typed in. We just typed those in. So we started at -90, then -60, -45, all the way down to 360 degrees. We had done that in class the other day. Then in column B, we used the radians formula in Excel, which is a function in Excel. It's a built-in function that will convert from angles in degrees to angles in radians. And we used that in column B to get radian measures for all of these angles, because we need those in order to calculate, in order to use the cosine functions. Anytime you're using cosine or sine or tangent or whatever in Excel, the angles need to be in radians. So that's why we have column B set up the way we do. Let's then type in our functions here. So in column C, I'm going to type equals and then cosine, parenthesis, and then the quantity that's in B3. Close parenthesis, just hit enter on that, and that we get the number 0 because cosine of -90 is 0. Now we need to just be careful when we're entering the function in column D. Just be careful where we put our parentheses and the fact that we do need lots of parentheses. So I'm typing equals 3 times cosine parenthesis 2 times another parenthesis. And then we don't have the letter T, but we have the cell B3 minus, And then I have pi parenthesis. So pi divided by 4. That's another built-in function in Excel. Anytime you're using the number pi, you can refer to it or reference it by pi parenthesis parenthesis divided by 4. And now we need two right parentheses, right parenthesis, right parenthesis, or right bracket, right bracket. So just double check and make sure all your brackets are lined up the way they should be. Make sure that the 2 is being multiplied by that entire quantity inside there, and that cosine is then being calculated on that entire quantity. And now we're going to add 4 at the end. Okay. So again, just really double check, make sure that you entered that formula in correctly. This is the hardest part for, honestly, because any tiny little typo could change everything that we do from this point on. So I'm going to select both of those cells, C3 and D3, and I'm going to click in the lower right corner and drag down. So fill the numbers down. I already had configured these cells too, by the way, to be centered so that I can read those numbers a little bit better. Okay, now that we have the table filled in, let's go over here and talk a little bit more about how we're going to answer these questions. Our goal is to find the amplitude, period, vertical shift, and phase shift of the new function. So I'm going to ask that you recall that the amplitude of cosine is just equal to 1 because it's half the distance from the maximum to the minimum. The period is 2 pi because that's how long it takes for it to repeat the pattern. And then we can use the point 0, 1 as because it's our maximum value. We're going to use our maximum value to determine what the phase shift, if there is any, is going to be by observing if the new maximum is a shift to either the left or to the right from from where it's supposed to be in the base function. So notice in the method that I have laid out here, we've already done the first part. We're going to create a table of values. So that we've done. But now we're going to mark all of our maximums with a certain color. So if we look at our cosine t column, maximum occurs at when y is equal to positive 1. So I'm going to make those kind of a pink color. So whenever we see positive 1 in the y value there, we're going to shade that in pink. So that shows you what your period is, okay? Let's go over to this column, column D. Can we identify the maximum there? It looks like it occurs when y is equal to positive 7. So I'm going to highlight that. That occurs here at 45 degrees, and then it occurs again at 225 degrees. And is that it? So yeah, those are the only two times that we see the maximum value occurring. So those are all the maximums. And now let's choose another color. I'm going to probably use gold for the minimums. So let's find one. We'll go into our cosine t column. We have -1. So -1 is the minimum. So let's change the color to like this light gold color. There's a minimum. So the minimum should occur halfway between the two maximums. They should be balanced out. So that's also going to happen over here. But I'm noticing that it's occurring more often too, like the gap is shorter. So the minimum value seems to be positive 1 over here. So I'm going to shade that gold. And then we have a gold down here. And then we have a gold down here. Those are the minimums. So I'm not even going to make a graph of this because I think it's a little too crazy. It's a little too nuts to try to figure out what's going on. I think it's just easier just looking at the numbers themselves. So so those are the minimum values. And All right, so when it comes to amplitude, so let's talk about amplitude first. We want to take 1/2 and multiply it by max minus min. So 1/2 times, in this case, 7 minus 1 of the new function now. We're not talking about cosine of t. We're talking about the new function that we just typed into column D. And the maximum value was y equals 7. The minimum value was y equals 1. 7 minus 1 is 6. 6 times 1/2 is equal to 3. So the amplitude of our new function is positive 3, which is 3 times as tall as cosine of t, because cosine of t has an amplitude of 1. So it looks like we have a vertical stretch. Let's talk about the period. The period of the function is going to be on the kind of how long does it take to get from one maximum to the other. So let's take the degrees and subtract. Okay, so where that occurs is what we're interested in. The period is the width on the t-axis. On the t-axis, how wide is the t-axis between two maximums? So the second one occurs at 225 degrees, and we're going to subtract the first one from it, which occurs at 45 degrees. So let me go and highlight those a little bit of a purple color as well. So we had 225 degrees and we had 45 degrees. That's going to be our period, okay? Because that's how long it takes to on the t-axis to get from one maximum to the other, to the next one. And in degrees, 225 minus 45 is 180. And we need to report that in radians. So we would say that that's just equal to pi. So I'm going to go ahead and use my equation, insert an equation here. You can also insert just a symbol, and that's just the number pi. So the period is pi. Let's talk about the vertical shift. This is a little bit more complicated to look at because, especially if you're just looking at the chart here, because it's not going to be how much the maximum changed by, because the maximum value went from positive 1 to positive 7. But if you recall, the amplitude also changed. So because the amplitude changed, we can't use the maximum value or the minimum value to determine what the vertical shift is. What we need to do is figure out where the point, where the 0 point went to. So like halfway between the maximum and the minimum is 0 on cosine of t. So on cosine of t, at 90 degrees, we had a y value of 0. And notice that occurs halfway between a maximum and a minimum. So if we look at the same kind of pattern over here, halfway between a maximum and a minimum value is actually right at the same, kind of at the same number. So just look for all of those halfway points. All of those halfway points are here, and I'm shading those in blue because those are going to be, that's going to tell us what our vertical shift is. The vertical shift went from 0 up to that value. So the vertical shift is from y equals 0 to y equals 4. Those are your halfway points between the maximum and the minimum. So the vertical shift is 4 units up because it's positive 4. Now let's talk about the phase shift. The phase shift is going to be how long it takes. So the width or difference in, not the width, sorry. It's the phase shift is where the new value of t, or new value of the angle where the maximum occurs. How did the maximum value change? Like, where did it shift to? So in the original cosine function, it would have been at the point 0, 1. So that's this point here. On our new graph, it occurs at 45 degrees. So look at your purples. Look at your purples. The purple point went from 0, 1 to 45 degrees, or in radians, that would be pi over 4, 7, right? So it shifted from 0 to 45 degrees. That's how we would state it here. So shift from 0 degrees to 45 degrees. And in radians, that means a shift of pi over 4 units to the right. So I'm going to go ahead and insert equation, put pi over 4 here, units to the right. And I say to the right because it's positive 45. It went from 0 to positive 45 degrees where the maximum is. So just to recap, the amplitude is equal to 3. The period is pi. The vertical shift, it was shifting. The entire graph was shifted 4 units up. And then the phase shift is a shift of pi over 4 units to the right. So like, subscribe, comment down below, share these videos with people if you think they'll find them useful. And that's how you use Excel to figure out amplitude, period, vertical shift, and phase shift of a transformed cosine or sine function.